Hello, and welcome to LabVIEW Basics number 2. My name is Grady King once again. This video is going to be a little bit less long than LabVIEW Basics number 1, just because there's a little bit less content. I didn't really section it off perfectly, but whatever. And let's just jump into it. Let me grab this. Alright. So let's go ahead and go to File and New and create a new project again, just so we can organize our stuff. And let's actually save this project. I realized I didn't save it before. You just need to save it. So LabVIEW Basics number 2. And alright, let me get organized here. And let's make a new VI. Just make a new blank VI. Alright, so the first thing I'm going to be going over is something called the select block. And select blocks are actually extremely important in terms of kind of deciding what you're going to be doing. Especially in our current LabVIEW architecture, it's one of the most important blocks in basically determining what you're going to be doing. So let's right click and go to structures. No, it's in comparison. And go to the select block. So you notice there's 3 inputs on the left and 1 input on the right. There's a boolean in the middle, and the top is true and the bottom is false. So essentially what this is if the input to the boolean is true, then the top value gets passed through, and if it's false, then the bottom value gets passed through. And I can display that. For the top is 2614 and the bottom is 4265. And let's create a boolean here and an indicator. And that I wanna alright. Yeah, so if we run it with the value being false, the bottom value gets passed through, and then if you hit if the value is true, the top value is going to be coming through. And the reason that this is kind of extremely powerful is because you can determine what you're going to be doing from this. So let's change these numbers to be some integers. So what I'm going to be doing is I'm going to be determining what we're doing based on 2 booleans. So let's make this A and duplicate this and make it B. So let's say if A is true, we want to be displaying the number 10. If B is true and A is false, we're going to be displaying the number 5. And if neither of them are true, then we're going to be displaying the number 0. And this is very easy to do. So if you right click and go to structures, comparison, go to select. If you pass in this A and we want to pass in number 10, then if A is true, the number 10 is going to be passed in. But if A is false, we want to be passing in whatever B is determining the number to be. So if we create another select block and pass this in, then whatever B is determining is going to be, if A is false, it's going to be whatever B is determining the number to be is going to be passing through. So if we make a 5 here and pass that in, if you think about it, if A is false, it's going to be passing this number through, and if B is true, 5 is going to be the number that's going to be passed in, so the output here is going to be 5. And if neither of them are true, then it's going to be 0. So if B is false, then 0 gets passed in and gets passed through. And then A is also false, so this number gets passed through to the output here. Output. And we can tell if that's true. Let me make this not look weird. So if neither of them are true, 0 gets passed through. If B is true but A is false, 5 gets passed in. And if A is true, no matter what B is, 10 is going to be passed through, because this is overriding everything down here. And you can especially see this if you go through the highlight execution, you can tell what that is. And that's a way to basically determine from a bunch of Boolean values one single output. And this kind of brings in the idea of priority. 10 is prioritized over 5 and 0 because if A is true, then 10 is always going to be there. Especially if this tree was like, say like, I don't know, like 8 long, this 10 is still going to be highest priority because no matter what, if A is true, 10 is going to be passed through. And this may make a little bit more sense with something called enums, which I'll explain in a little bit. But this is what we call a select tree, and it's very important in structuring code, at least in our architecture. All right, so that's what I'm going to be talking about for select blocks. And let's go on to a different thing. So the next thing I'm going to be talking about is something called arrays. If you've ever worked in any other programming language, you might know what an array is. But if you don't know what an array is, it's essentially, it's kind of like a list of either numbers or booleans or strings or whatever sort of data type you want. So let's just make an array and you might see what I'm talking about here. So if you right click and go to data containers, or right click on the front panel, go to data containers and select the array. This is actually a blank array right now. There's no data type specified. If you look in the top right corner actually in this context help, by the way, this is the context help window, it's actually the type void because there's no type in it. So what do you do to define the type? It's just right click and just put in some sort of like controller indicator of that type. So I'm going to be putting a numeric in there. And then now if you look at that, it's an array, 1D array of numeric type. And if you drag this bottom dot here, you'll see that there's a list of numbers here. And so as I put in numbers, you can see it's just a list of a bunch of different numbers. And this is useful because there's a lot of data processing as well as sort of decision making that you can make based on this. And it's an easy way to bundle information together. And there's a few other use cases that I'm not thinking of right now, but it's a very useful sort of data structure. So this is one way to construct an array. A different way to construct an array is something that you can do in the block diagram instead. If you right click and go to the array tab, there's a bunch of different things here. But the build array is a different way to construct an array. So you see there's only one slot here. If you go, there's a super tiny dot at the bottom there. If you drag that out, you'll see it's a kind of a similar, it expands out. And if you create some numeric constants here, then you can pass these in here. Oops. And if you create an indicator here and drag this out, it's very similar to the control. Then you see you make an array that is determined by whatever gets passed into the left here. And this is an array to programmatically make arrays. Another way to programmatically make arrays is actually something called, well, you already know what it is. It's a for loop. So if you right click and go to structures and go to for loop, what you can do is let's make an array that's like 10 long. And let's just make the number that all of them are 2614. So if you actually pass this out, you'll see that there's this sort of thing called an auto index tunnel. Oh, and by the way, you might be able to excuse me, you might be able to tell the difference between just a single number in the array because the arrays are a thicker line, if you see here. So this is an array of the float numeric type, and it's bold, so you know that it's an array. This is just a thin line, so you know it's just one number. So back to for loops. whenever you pass out this number, you see that there's this sort of thing called an auto index tunnel. And there's a few different options here for whenever you pass a number out of a loop. If you look at tunnel mode, there's the last value, which basically just passes out the last value that comes out of that block. There's indexing, which essentially creates an array of all of the values that get passed out of the loop. And then concatenating is more for like strings, where it basically creates a string where it adds each output to the end of the preceding output. So if you pass out like an H and then an E, it'll concatenate the E onto the H, and then an L, O, and that'll create hello. So that's a way to like programmatically create a string if you really wanted to. But that's a little less used. Last value and indexing are really the more used. And the conditional, basically, there's a value there's a condition here. If it's false, it won't pass it out. And if it's true, then it will pass it out. So if you wanted to create something where it only adds to the array when a certain condition is true, then you can do that. That's kind of useful. But anyways, if we just wanted to make an array that's 10 long with 2614, then with this auto indexing tunnel set to indexing, it'll create an array of all the values that get passed out. And if we run that, you'll see that we get what we expect. There's actually a way to do this with just a block. So if you go to array and initialize array, there's actually, you notice it's very similar. If you pass in a 10 to this dimension size, which a dimension is, you can have a one-dimensional array, which is basically what this is. But a two-dimensional array has it's basically each index of the array is an array itself. So instead of having just one line up and down, it looks more like an Excel sheet. And that can be useful in different scenarios, but I'm getting ahead of myself here. So if we just use this, this creates an array that's 10 long with every element being 2614. So that's just a second way or a third way to make an array. If we wanted to make this a little more useful, we could actually make an array that counts up. So instead, we could pass in this loop iteration, and that would basically every loop cycle will pass the loop number, and you see that creates that. That's a little bit more useful, and there's a few. That's basically a way to make an array based on whatever is happening in here, and that's pretty useful. So how would we actually get a certain number out of this array? There's something called, if you go to array, something called index array, and this is a way to get an element at a certain index. And if you notice, arrays start at 0 and then count up, just like loop iterations, just like everything else in programming. So let's say we wanted to grab, let's use this array because it's kind of obvious what's in the array here. Say we wanted to grab the third element. So the third element, if we go over here, remember we're counting from 0, so this would be 26 would be 0, 14 would be 1, 26 would be 2, and then 41 would be the third element. So let's just pass this in. And all you have to do is right click and create a constant and pass in a 3. And then you see that this is a thin line, and that means that it's a number. And you see that gives the result we expect. If we pass in a 2, then we'll get the second element, which remember 0, 1, 2, and 1, etc. You get a 14. And that's just a way to get certain numbers out of an array. And that's all I'm going to give you about arrays. There's a lot more to do with it. Obviously, you can see there's a lot of things here. But that's all I need to know right now about arrays. You'll get more into them later. But let's save that. A slow intro. And let's go to the next thing. This next thing is a little bit more abstract, but it's very useful, and it's kind of an integral part of our architecture, and it's something called clusters. And a cluster is basically a way to, you know how arrays are a way to kind of bundle a bunch of numbers together, sort of, it keeps it in an organized way. Clusters is sort of a way to organize a bunch of different numbers of different types. So let me show you what I mean. If you right click on the front panel and go to data containers and cluster, you see that the same thing that happened to the array is here. There's nothing in the cluster, so it's just a black sort of color. So if we put in a numeric here, you can call this whatever. But we can also put in things like booleans. So call this bool, and you can put in a string. Call it, I don't know. And you see that this cluster turns pink, and that means that it's a cluster of a bunch of different types of elements. And so this is basically a way to, it bundles everything together. So if we go to cluster class invariant and go to unbundle, you'll see that if we pass this in, there's all those different types, and you can just access each one of them. A little bit more of an intuitive way to access clusters is something called unbundle by name. If you pass that in there, you'll see that if you drag this out, it actually has each of their names here. If you look at these names, they correspond. And that makes it so that's a little bit easier. For example, one way that we use clusters is for joysticks or Xbox controllers or whatever you want to call them. Basically, there's a bunch of different data here, right? There's like joystick up and down, left and right. There's all of these buttons. There's the direction that this D-pad's going. All these buttons. The joysticks on the back here. The bumpers. So this would be kind of annoying if you had to individually pass around all of these different types of data. So what we do is we put all of this data into one cluster, and then all we have to do is just access one of the elements in the cluster, and it makes it a lot easier. And you don't really have to think as much about, is the right joystick back here, or trigger, that's what it's called. Is the right trigger back here, is that the fourth element or the fifth element in the array? You just have to worry about the name, and then you can just select it and access it very easily. That's one way that we use clusters. It's also used in the autonomous for, this is kind of a little bit broad, but for basically autonomous is structured in a queue, and each element in the queue has a bunch of different information in it, and that's organized into a cluster. That's kind of a little far out there, but yeah, that's what you use clusters for. You can programmatically create clusters by going to bundle my name. So if you just have a bunch of different types of data here, we can just pass it in here and create a new cluster here. This bundle by name actually wouldn't work because these don't have names. So if you actually change these to controls, oops. If you right click and change to control, then you can do this. Change to control. And you create a, here, we just need a bundle by, without the names. Bundle. Good. Then we can create the bundle here. Bundle by name is a little bit weird like that, but there we go. Now we have our cluster here, and if we change any of these elements here, then the corresponding numbers will change in this cluster. And that's kind of a another useful way to cluster information together. So let's save that. That'll be useful to know for later whenever you're learning the architecture. And now for another thing. Now we're going to go for something called enums. And enums is kind of a way, it's not necessarily easier for the computer, but it's easier for humans to kind of process. So if we right click here and go to, I think it's numeric. It's not numeric. Go to enum, bring in enum, and create an enum. Basically, if you right click and hit edit items, you'll see that there's this edit items window, and there's this kind of items thing on the left and this values on the right. So if I make let's make one Abe Lincoln, one George Washington, one Teddy Roosevelt, and I don't know, let's make one Obama, because no one knows Obama's last name. I'm just gonna make it Obama. And so you'll see that there's a list of these 4 different presidents. And you'll actually notice that there are values associated with these presidents. So Abe Lincoln's the 0, George Washington's 1, Teddy Roosevelt is 2, and Obama is 3. And the most common usage of an enum is actually in a case structure. So if you right click and go to structures and case structure, if you pass this enum in, you'll see that you have a few of these cases, like Abe Lincoln and George Washington. But if you right click and actually make, if you do add case for every value, it kind of automatically does this for you. And you'll see that it creates a case for every value of the enum. And so this kind of allows you to, it's a little bit more of an abstraction. Technically what this enum is doing is it's passing in a number, and these cases correspond with each number. So Abe Lincoln actually corresponds with 0, George Washington with 1. But this allows you to kind of think about how you want to structure kind of what you want to do based on whatever this enum is. So I don't have any quotes from each of these presidents, but I'll make some up. Abe Lincoln says, "I am a president." George Washington says, "I am the old president." Teddy Roosevelt says, "I am a, I don't know, ecologically friendly president." I don't know. I'm just making stuff up. Obama says, "I am a recent president." And if we pass these all out, it's going to do what you kind of expect. Just like with numbers, it'll do the same thing. And create an indicator. So Abe Lincoln says, "I'm a president." Obama says, "I'm a recent president," etc. You get the idea. But essentially this is kind of like I said, it's an abstraction of what a computer is actually doing, but it allows you to think about what you want a computer to do and sort of create cases for that. So it's kind of the nicest way to use a case structure. It's the easiest way to think about it, and it's pretty nice. So that's a way to do enums. By the way, to determine this enum that's being passed in, you can use a select tree, and that's kind of the main idea of how we determine what we're doing on a robot. Is we determine which enum we want to pass into the case structure, and this case structure is what the robot actually does. And you can right click and create constants, and this is your enum constant, and you just determine whatever enum is being passed in here based on the select tree. So if we create a very basic select tree here, I'm just going to do 2 of the presidents. Then if it's true, we pass in Abe Lincoln, and if it's false, we pass in George Washington. And this is the very basic idea of how, based on Boolean values, we determine what enum we're using, and then the enum that gets passed in the case structure, the code inside the case structure, is what gets passed out into the robot. So you'll see, based on whatever value this select tree is going to be making, this is a select tree of 1, based on whatever this select tree is outputting on this enum is what is going to come out of the code. And so that's kind of a extremely basic overview of like the general structure, how LabVIEW architecture works in robotics. Is you take data in, determine what you're doing, and then you do the thing. But let's save that as enums. There's one other thing I want to mention, which is something very simple, which is something called a sub-VI. So let's actually go back to the arrays here. So sub-VIs are something that kind of clean up your code. It makes it so that you can basically take a block of code and squish it into just one block. So if we take, let's say we wanted to pass in the number 10 to a block of code, and we just wanted to get this array out, what you can do is you can select this block of code, like this is unsightly, this is so big. If we could go to edit and create sub-VI, what you actually do is you create your own block. Basically you pass in the numeric and the array comes out. And you'll notice if you open up this sub-VI, you have values on the front panel, which these numbers are overwriting whenever they get passed in, and these values get passed into this block, goes into this output, and this output comes back into the overall block diagram and gets passed out. And this is super useful. As you get more and more complex code, these sub-VIs get increasingly larger and larger, and it's nice to have that block there, especially for code that you reuse all the time. There's a few things like certain logic gates that we use all the time that you can really just use a sub-VI for, so you don't have to be copy-pasting code all over. You can just use sub-VIs. And that's just a useful thing to know. But that's actually all I have for today's video, and we're going to go into the challenges. Your first challenge is to create an array of n length inputted from a numeric control where the even indexes contain I, which is the index of the point in the array, so index 2 would contain 2, index 4 would contain 4, and then the odd indexes contain 2614. So for example, if we create an array of 2, the 0th index contains 0 because it's even, and 2614 contains odd. If you create an array of 10 length, the even indexes 0, 2, 4 contain those indexes, and the odds contain 2614. Your second challenge is to create a continuous while loop with a wait time of 50 milliseconds. Create a numeric control x in seconds, a string indicator called output, and a numeric control called seconds elapsed. The output will contain 2614 for the first x seconds inputted here that the loop runs, and then Mars for all of time after that. So if I input a 5 and run it, seconds elapsed counts up, contains 2614, then once it hits 5, it contains Mars for the rest of all eternity. For your third challenge, there is a numeric control called starting value and 4 Boolean buttons on the front panel: exponential increase, linear increase, exponential decrease, and linear decrease. Additionally, there are two numeric controls called exponential x and linear x. Using a select tree, create this behavior. Increased commands override decreased commands, and exponential commands override linear commands. So exponential increase is the top priority, linear increase is the second highest priority, exponential decrease is the third highest, linear decrease is the fourth highest, and then no behavior is the least priority. The program starts with this starting value, and then every loop cycle, which is 200 milliseconds, the number will change. If the command is exponential increase, the number is put to the power of the exponential x. Exponential decrease will put the number to the reciprocal of exponential x. So it'll be the number to the power of 1 over exponential x. Linear increase will add linear x to the number, and decrease will subtract linear x from the number. Display the current value and the current command on the front panel. So if you put in 1.2 and 5 and start at the number 5, whenever nothing's selected, the value is 5 and there's no command. If you go to exponential increase, you see that there's some clear exponential increase there. It goes up very quickly. If we go to exponential decrease, you see it decreases very similarly. If we do linear increase, it adds 5 every loop cycle, which is the linear x. If you go decrease, it subtracts the linear x. Additionally, if we do exponential increase, that overrides everything else, so the command is there, and then linear increase overrides all of these other ones, then exponential decrease, then linear decrease, and then nothing. So those are the priorities there, and good luck. I would like to show you where the exponential block is because it's kind of very deep in some folders. So if you right click on the block diagram, go to mathematics, go to elementary, go to exponential, then here's x to the power of y, and that's how you'll get that exponential increase and decrease. You'll plug in the number to x, and then you'll plug in whatever you want x to be the power of to y, and that'll give you your output. Alright, good luck on your challenges. Be sure to let me or any other programmer know if you have any questions or comments or anything, and have a great day.